All right, let's talk about adding and subtracting rationals. Take 4. All right, so you guys know that when we add or subtract fractions, we need common denominators, right? So it's like adding people to your family. You want things in common before you add them to your family. So if I had something as simple as 1/2 plus 3/2, and since the bottom is the same, we would add the top and keep the bottom. So now we'll have 4/2, which we can reduce to 2. So something nice and simple like that, just so that you remember that. And if we had another example like 2/15 plus 5/12. Now, some of you guys are really good at finding the LCD with numbers. However, if not, I showed you a different way. I said to break the denominator down to product of primes. I don't know if you guys remember me saying that. So let's put 15 in red. So 15, if it breaks down to primes, it'll be 3 times 5. And if I was to break 12 down to primes, that would be 2 times 2 times 3. And one of the things I said was we're going to look at that fraction and that fraction. So we're going to look at those two denominators as sisters. So one sister is jealous of the other because they have something that they don't have. So if I was a red sister, I'm going to ask myself, what does the blue sister have that I don't have? And she's going to be like, well, I have a 3, she has a 3, but she has 2 2s that I don't have, okay? And if we multiply something on the bottom, we have to multiply it on top, right? Now, the blue sister is going to ask herself the same question. What does the red sister have that I don't have? I have 2 2s. She has now 2 2s. I have a 3, and she already has a 3. But the part that I'm missing that she has is a 5. So I'll do that. All right. With that being said, then what would happen is you obviously multiply this. So the top is going to be 8 over, and the bottom is going to be 2 times 2 times 3 times 5, and that is going to give me 60. Plus 5 times 5 is 25, and 2 times 2 times 3 times 5, which is the same exact denominator, so that's 60. So now we have a common denominator. So we will add the top. So the top is going to give us a 33 over 60. And then if you notice, we can reduce 3 goes in the top 11 times, and 3 goes in the bottom 20 times. So therefore, that would be my answer. All right. As you guys know, in this chapter, what we're going to be, our tops and bottoms are going to be a little bit different. It's not going to just be numbers. It's not just going to be numbers and variables. It's going to be, 2 terms, 3 terms, or binomial and trinomials. And in fact, maybe even sometimes 4 terms where we're going to have to factor, meaning GCF, and then figure out what's left. Is it a binomial? Is it the difference of 2 squares? Do we use their AC method when it's a trinomial, and then factor by grouping if it's 4 terms? So I think the easiest way to do this would be for me to start with an example and then write down the steps as we go so that you can kind of see both things going on. So here we go. So let's use the first example. So example 1. So example 1. Let's say x plus 1 over x squared minus 6x plus 8 minus a 3 over and x squared minus 16. Okay, so let's look at that. So step 1 is going to be put parentheses around all binomials. Okay, so that means around the x plus 1 and the x squared minus 16. Now the x squared minus 16 is not as important because if you notice that has no GCF, and that is the difference of two squares because it is two terms. But the x plus 1, it's already done factoring, it can't factor any further. So therefore, the parentheses for the x plus 1 is way more important to do, but it's easier just to say put parentheses around all the binomials. So that's my step 1. What's step 2? Well, step 2 is for me to factor the bottoms. Okay, so let's go and do that. So on top I have a x plus 1. Awesome. And the bottom is a trinomial, so I would use the AC method. So that's going to be an x minus 2 and an x minus 4 minus a 3. And that is a binomial, so difference of two squares. So that's going to be an x minus 4 and a x plus 4. Awesome. All right. What's step 3? Step 3 is going to be to find restrictions. To find restriction, we're going to set the bottom, in this case bottoms, equal to 0. So I'm going to have x minus 2 equals 0, x minus 4 equals 0, x minus 4 equals 0, and x plus 4 equals 0. So we have x equals 2, x equals 4, x equals 4, x equals negative 4. So my restrictions are going to be x cannot equal 2, negative 4, 2, and 4. Excellent. So now we found our restrictions. What is the next step? We just use blue. Let's use green. So what's step 4? Step 4 is to get all fractions to have the same bottoms, which is known as your LCD. All right, so here we go. So let me rewrite this problem here. We have x plus 1 minus 3. Okay, so, oh shoot, okay. You had x minus 2, x minus 4. And that will work. And then we got x minus 4 and x plus 4. Okay, so this is where we're basically doing the LCD. So again, we're going to look at this sister versus, let's try that again, versus this sister. So the red sister versus the blue sister. So the red sister is going to say, what does the blue sister have that I don't have? So she's going to look and she goes, well, she has an x plus 4 and I don't have an x plus 4, so I want an x plus 4. Okay. Then the blue sister is going to ask herself, what does the red sister have that I don't have? Well, she has an x minus 2 that I don't have. And anything I multiply the bottom by, I got to multiply the top by. And if you look at the two bottoms right now, they both have x minus 2, they both have x minus 4, and they both have an x plus 4. Okay? And there's only one of each. All right? So that means I have, right now, I have, whoa. Right now I have an x plus 1, x plus 4, over x minus 2, x minus 4, x plus 4, minus 3, over x minus 4, x plus 4, oops, forgot this, and x minus 2. So that's what I have in step 4. So step 5, let's see here. Let's use that one. Why not? So let's see, step 5. Step 5 is going to be add or subtract the top. And as a warning, may need to distribute. So we're going to add or subtract the top, comma, keep the bottom. Okay. And when I talk about distribute, I'm talking about double distribute slash foiling, and then just regular distribute. So if you look over here, you'll see that. So with step 5, I'm going to have to FOIL here and distribute here. And I'm not just distributing the 3, I'm distributing a negative 3. I'm going to show you guys that right now. So add and subtract the top. So I'm going to do it in 2 steps just so you guys can see what's going on. And I would prefer that you do these 2 steps because then you wouldn't miss that negative 3 that I'm talking about. So you'll see it right now. So we have an x plus 1, x plus 4, minus 3 times x minus 2. That's subtracting the top. And then I am going to keep the bottom. So keeping the bottom, x minus 2, x minus 4, x plus 4. Okay? So with that being said, now, as I said, I may need to distribute. So again, I go back to the top being foiling, and the first part foiling, the second part distribute. So when I FOIL this piece, I get x squared plus 4x plus x plus 4. And then I'm going to be distributing this negative 3. And that's going to be a negative 3x plus 6. And put that all over x minus 2, x minus 4, and x plus 4. So I'm going to use the highlighter to kind of not underline but overline these. So I have the x, x, and x here. And then I have the 4 and the 6. And the x squared is by itself. So therefore, what do I have? I have x squared. 4x plus x is 5x minus 3x is a plus 2x. And then the 4 and 6 is a plus 10. over x minus 2, x minus 4, x plus 4. Okay, so that is the end of step 5. So let's see what I haven't used. Let's go with the purple. Or not. All right, so step 6. So step 6 is going to be simplify. And the warning here is that you may need to factor. So what do I mean by that? So if you notice that the top is a trinomial. And since the top is a trinomial, I need to try to factor it. Even if it's a binomial, you still got to ask yourself, is it the difference of 2 squares? If it's 4 terms, you're going to have to see if you can do factor by grouping to it. So if I did the AC method on the top, A times C is equal to 10, B is equal to 2. So do I have 2 numbers multiplied together to give you positive 10, and the same 2 numbers added together to give you positive 2? And the answer is no, you can't. So therefore, I can't simplify anymore. So therefore, this is my answer. So x squared plus 2x plus 10 over x minus 2, x minus 4, x plus 4, comma, x cannot equal to negative 4, 2, and 4. Ladies and gentlemen, you have just solved your first addition and subtraction of rational expressions. All right, so that's a pretty long problem, if you notice. And me busting your chops about really getting good at, factoring, this is the reason why. Because this is a pretty long problem as it is. Obviously, with a lot of details and a lot of this stuff, you're probably going to be skipping, which I understand. But at the same time, if you're not very good at it, don't skip it. Follow these steps. Follow these as is. And once you get good at it, then you can probably skip some of the steps. But if not, stay with it. All right? Be disciplined with it. So let's look at another example. Oh, no. Doop, 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 doop. All right, let's look at another example. How do I want to do this? All right. Yeah, let's do this one. So example 2. I got 7 over x squared minus x minus 2 minus x minus 1 over x squared plus 4x plus 3. Okie dokie. So, what's step 1? Darn it. Step 1 was parentheses around all by nomios. Step 1 is pretty easy. Step 2, get some blue. Step 2 was to factor the bottoms. Okay, so I have 7 over, so when I look at the bottom, I can do the AC method, and that's going to come out to be x minus 2, x plus 1, minus x minus 1, Oh, another trinomial, another AC method. This is going to be an x plus 3 and an x plus 1. Awesome. So that's done. And what color did I use for step 3? Orange. So step 3 was to find restrictions. So that means I got x minus 2 equals 0, x plus 1 equals 0, x plus 3 equals 0, x plus 1 equals 0. So I have x cannot equal to 2, x cannot, well, negative 1, that's fine. X cannot equal to negative 3, and x cannot equal to negative 1. So that means my restrictions are x cannot equal to negative 3, negative 1, and 2. Okay? We have to remember to bring that down with us later. Okay. No, I don't want to move that. I just want to do these. Okay, focus. Okay, step 4 was in what color? Green. So step 4, get fractions to have the same bottoms, or the LCD. All right, okie dokie. So let me rewrite this. 7 x minus 2, x plus 1, minus x minus 1, x plus 3, x plus 1. That's what I forgot to do. So we're going to make this one red. And this one blue. All right? So we're going to ask ourselves, what does the blue sister have that I don't have? Well, blue sister has an x plus 3 that I don't have. And the blue sister is going to say, what does the red sister have that I don't have? An x minus 2. Okie dokie. All right, so what do I have on top? I have 7 times x plus 3 over x minus 2, x plus 1, x plus 3, minus x minus 1, x minus 2, over x plus 3, x plus 1, x minus 2. So we notice the bottom, all the same. All right? So what did I write step 5 in pink? So step 5 was to add or subtract the top and keep the bottom. Okay? All right. So let's write the top out is 7 times x plus 3 minus x minus 1, x minus 2, all over x minus 2, x plus 1, x plus 3. Okay? So the first group here is going to be distribute, so 7x plus 21 minus x squared minus 2x minus x plus 2. Now notice that I put parentheses around that distributing because of that subtraction sign in front of it. You can either distribute the negative into the first factor and then FOIL, but people get confused on, do they distribute to the first group or do they distribute to both groups? The answer to that question is you only distribute to the first group. So for me, I think it's easier just to FOIL it and then just distribute the negative through. It's way easier that way, so that's why I keep it this way, and I would tell you to stay that way as well, okay? So that's over x minus 2, x plus 1, x plus 3. So now I got to distribute that negative through, so I get 7x plus 21 minus x squared plus 2x. I guess I could have combined like terms first, plus x minus 2 over x minus 2, x plus 1, x plus 3. Now let's use a highlighter. I got 7x here, 2x and an x. And then I have a 21 and a negative 2. So that means I have a negative x squared, 7x, 9x, 10x. And then I have a 21 minus 2, that's a plus 19, all over x minus 2, x plus 1, x plus 3. So I have a trinomial on top. Step 6 was in purple. Dark purple. Step 6. So step 6 is going to be simplify. So if we look at step 6, I see a trinomial. Let's see if we can factor it. A times C gives you negative 19. B is equal to 10. So the question is, can I find two numbers multiplied together to give you negative 19? But yet, same two numbers added together to give you 10. And the answer is no. So I'm left with this. X minus 2, x plus 1, x plus 3, comma, x cannot equal to negative 3, negative 1, and 2. Okay, so there's my answer. Any questions? So I did I did two subtraction problems, looks like. And I think the addition problem tends to be pretty easy. It's the subtraction problems that can kind of catch you off guard. So I'm going to end here, and hopefully that these two examples will kind of, get you ready for all of these other problems. And I hope that is all understandable. I will also export these PDFs and post them as well. But I hope you enjoy. And again, thank you for catching up on these homeworks, and I'll see you guys on Monday.